Hello and welcome, dear listeners. You're tuning in to the ReGENERATE project podcast on regenerative agriculture. Join us as we explore new approaches to soil, landscape, and the future of farming. Hope you enjoyed the episode. Your host, Radim Kužel.
Since winter, a lack of water in the soil has already been apparent in the Czech Republic, and the snow-poor winter contributed to the development of soil drought, which continues to deepen. What does this mean for Czech farmers? And how can Czech agriculture adapt to this new reality? Today, I will talk about this with Professor Zdeněk Žalud from CzechGlobe, the Global Change Research Institute of the Czech Academy of Sciences. Professor Zdeněk Žalud is a leading Czech expert on the impacts of climate change on agriculture and the landscape, and he has long focused on bioclimatology, biometeorology, and the impacts of climate on agrosystems. Good day. If we look at the last 10 to 20 years of Czech agriculture, what do you think is the most visible change we can see regarding the climate?
Clearly, it is the extreme that you mentioned in your introduction, and that is the onset of drought. Of course, not every year we experience an intense drought that would have a major impact on agriculture and our landscape, but if we compare the current state, meaning the last 15 to 20 years, with what we had here, let's say, in the 1960s and 1970s, then the increase in drought is enormous.
And which regions or production areas in the Czech Republic are currently the most affected by this?
On Intersucho, we monitor the basic map as a deviation of soil moisture from the long-term average, which I believe is from 1961 to 2015. And if you looked at the map right now, you would find that it is mainly the Vysočina region, but also our mountains. Paradoxically, the lowlands appear white, meaning drought is only visible in the upper soil layer there. There is still some water deeper down, but that does not mean there is enough water there. It means that the situation is essentially normal. So what is important for every Intersucho user is to look at the introductory map as a deviation from the long-term average. And I strongly recommend immediately clicking on the adjacent map where you can see the soil moisture status itself, meaning how saturated the soil is in percentage terms. And if you combine these two maps, you get a perfect overview of what the drought situation actually looks like. And if you click on your own district, or interactively even down to your own cadastral area, you can see the situation directly on your fields.
So, for example, the South Moravian region, which has long been considered drier, may currently not appear deficit-like on the primary map. If we look at the last 10 to 20 years of Czech agriculture, what do you think is the most visible change we can see regarding the climate?
You know, it may not, but there is another reason connected to what you mentioned about winter. Winter started very promisingly. There was relatively a lot of snow in December. Then it changed, and according to our data, there was about 40% less snow than the long-term average. And it is true that this is the first condition for drought to develop in spring. And in the lowlands, there was relatively more snow water than, for example, in Vysočina or in the mountains. So that is the first condition. But please note, the current situation is not based only on winter conditions. There are two other extremely important aspects explaining why we currently have an emerging drought episode. The second aspect is that spring started 3 weeks earlier. And the moment vegetation wakes up 3 weeks earlier, of course it also starts consuming water 3 weeks earlier, meaning it takes much more water than in a normal year. Consequently, the water begins to disappear and becomes lacking. And the third, and actually the most important parameter explaining the current developing drought, is of course the precipitation situation. If you look at South Moravia in March, the Brno country district had 9 millimeters, in April 14 millimeters. And in many regions of the Czech Republic, precipitation totals are really only in the lower tens of millimeters. So that is the third parameter. It simply is not raining.
And how is this currently affecting the condition of crops in the fields? Are we already seeing some effect? Or are the crops still holding on?
If you travel around the Czech Republic at the end of April, you will still see it more or less green. Yes, upon closer inspection you may already notice that in some crops, shrubs, or trees, the leaves are beginning to dry slightly. Gardeners listening to me right now are saying, well, we water every other day. Yes, that is true. On the other hand, there is still some water left in the soil, and the country is green. But the situation is very serious, especially considering the short-term forecast. Let's be honest, weather forecasts in the Czech Republic are reliable for temperature and wind for about 10 days, and for precipitation maybe 3 days. But in this case, I would trust the precipitation forecast further ahead as well, because we currently have a fairly stable high-pressure system, which means there will be no rainfall. And if any significant rainfall does arrive, it may only come in 8, 10, or 12 days, and likely less rather than more. So nature's response right now is, yes, there is still some water there. The first signs of drought are appearing even on crops, and of course those who are beginning to sow spring crops know very well that the crops may not emerge at all, or that emergence could be very delayed.
And what exactly causes these changes in climate? Or why do these drought periods keep returning? We have it this year. There were major droughts a few years ago as well, and it always seems to come back after some time. What causes it?
Well, I would correct you there. Drought is not a periodic phenomenon. It is a totally aperiodic phenomenon. That means drought has always existed here. We have mapped the Czech Republic back roughly to 100 BC, meaning about 2,120 years into the past, and we know that drought has always been part of our climate. There have always been dry years, but in the vast majority of cases these dry years were caused by several months without rain. That means there was an anomalous synoptic situation. For example, high-pressure systems accumulated and precipitation truly did not occur for several months, and therefore drought appeared. What is paradoxical is that in the last 20 years, we have drought even in years when rainfall totals are normal. And we may ask why. The answer is very simple. Since the 1960s, temperatures in the Czech Republic have risen by 2.4 degrees Celsius. And nobody needs to be a meteorologist to understand that if temperatures rise this much, evaporation must also increase significantly. And that is the reason why we have drought, because precipitation amounts have not changed since the 1960s. There are other precipitation-related problems. Distribution is changing, winter precipitation changes its form, but annual totals are more or less the same. However, higher temperatures equal higher evaporation, and that is why we now have far more drought.
And which agricultural crops, if we return to agriculture, are the most vulnerable to these changes in precipitation distribution throughout the year?
By their very nature, spring crops are the most vulnerable. One of the autonomous adaptation measures, and let me explain that, because of course we need to adapt to climate change, and autonomous adaptation means we do not need to tell farmers what to do. They can see it and feel it themselves. Is that in drought-threatened regions, meaning lowlands regardless of the current state, spring crops are disappearing. The reason is simple. Winter crops develop a root system during autumn, and these roots are then used in spring to draw water from deeper layers. Spring crops, which are sown only a few centimeters deep, do not have this advantage. So it is mainly spring crops, for example spring barley.
I asked because I want to connect it with experiences from Europe or Southern Europe, where we hear reports from France, for example, where farmers who historically grew maize are moving away from it due to lower rainfall and replacing it with sorghum, which seems to cope better with reduced precipitation. Meanwhile, in the far south of France, which historically was a region for chickpea cultivation, it is now apparently becoming too dry even for chickpeas, which are naturally drought-tolerant plants. And if I go even further south to Spain, farmers in dry regions are basically using direct seeding systems and growing only winter crops because the drought there is so severe. What are your experiences with European agriculture, and how farmers there have managed to adapt to these changes in rainfall patterns across Europe?
A very interesting situation exists not only in the south, but also in the north, though perhaps we will get to that later. But regarding the Mediterranean and southern regions, yes, I have had the opportunity to travel through southern Spain and speak with farmers as well as researchers about how they are responding to climate change. First of all, climate change is taken incredibly seriously there. Weather extremes are damaging not only agricultural landscapes, but also cities. You may have heard about the very frequent floods, which are, among other things, a consequence of the extremely warm Mediterranean Sea. We could easily discuss the situation in September 2024, which eventually affected us as well through the floods we experienced here. So this region is heavily suffering from extremes and drought. They respond mainly in two ways. First, and I'll simplify it greatly, wherever possible, water infrastructure projects are being planned. They understand very well that they must accumulate water. Note that there is retention, meaning holding water in the landscape and soil, and there is accumulation, meaning storage in reservoirs. They must accumulate water during wet periods and then use it mainly for irrigation. It is no secret that irrigation plays an enormous role in these regions. The second adaptation direction that is being strongly developed there is breeding. They are using the potential of so-called new genomic techniques. Farmers want new crops, they want old crops with new traits, and they want old crops but new varieties. For example, we visited a research station where fenugreek was being prepared. We asked whether this would become a crop of the future. They said, "This used to grow here in the past. These are ancient varieties which functioned here in these extreme heat and drought conditions before humans started irrigating and using modern technologies. And today they are once again placing their trust in these older plants." And as you mentioned, no one plows there anymore. Yes, that is true. No-till farming systems absolutely dominate there.
And since you mentioned plowing, from your perspective, what is the biggest limitation or problem with plowing for farmers? What can it actually cause?
Well, we are stepping onto thin ice here, because of course there are supporters of plowing and also, to some extent, opponents of plowing. So I would limit the view strictly to my own, meaning a climatological or agro-meteorological perspective. And that perspective says that plowing is probably the most reliable way to lose the remaining water in the soil during a dry year. So from the perspective of water conservation, no plowing. I would definitely recommend reduced tillage technologies or regenerative agriculture practices, although we also know there are disadvantages on the other side. And please, there is one more aspect which, from my perspective, speaks against plowing. Our research shows that plowing releases the most carbon dioxide from the soil when compared to other technologies and tillage systems. And carbon dioxide is the primary greenhouse gas whose increasing concentration in the atmosphere intensifies the otherwise very useful greenhouse effect and increases temperatures.
You touched a bit on regenerative agriculture, or mentioned it, which is the main topic of this podcast. What is your view of this style of farming from a bioclimatological perspective? What can permanent soil cover, reduced tillage, or different crop rotations bring? Or could this also be the answer to how to improve adaptation to climate change in the long term?
Yes, regenerative agriculture belongs to the group of so-called climate-friendly farming systems, or climate-friendly agriculture. And whenever I get a question about cover crops, I always remember one event that took place in Lednice in Moravia. At the time, Marian Jurečka was the Minister of Agriculture, and we were sitting next to each other in front of a hall full of farmers. He was criticizing them for not using the subsidy program for cover crops, that practically nobody had applied for it. Then one farmer stood up and said, "You know, we are very afraid that a cover crop is also a crop, and it will use up the water we need for the main crop. So we are worried that we will essentially lose water because of the cover crop." Current experience and research show that it is actually the opposite, that cover crops, which ensure permanent soil cover even during the summer months, prevent drying out. Because again, from my perspective as a bioclimatologist, the greatest evil we have in the landscape is evaporation. And attention, we have several types of evaporation. There is so-called evaporation to explain exactly what it is. That is evaporation from soil and non-living surfaces such as water, soil, or snow. Of course, we are interested in soil, and that is the lost water. If we talked about physiological evaporation, which is transpiration, on the contrary, that is what we want. That is the water that passes through the plant, through the cover crop, carrying nutrients into the plant and ultimately creating biomass, yield-forming elements, and yield. So reducing evaporation, which cover crops naturally help with, is an excellent way to conserve water. Likewise, cover crops, and now I would add species-diverse cover crops, are part of regenerative systems. For various reasons, there must be brassicas that quickly shade the surface, meaning the soil. There must be grasses that create a relatively rich root system and add a lot of organic matter. There can be something with a taproot that breaks through compaction and many other species, each bringing something extra so that a diverse mixture is created and the root exudates become very nutritious.
From my perspective, it is important not only to have a diverse mixture in the field, but also a diverse landscape overall around the fields. We are now encountering a big debate about field size, that agricultural fields in the Czech Republic are too large compared to Western Europe. Does our Czech landscape and the large size of agricultural parcels have any influence on how the climate behaves here, or possibly on how drought develops?
I would remind you of the year 2018. At that time, there was a very strong drought episode showing that the Czech Republic was significantly affected, and the Czech Agrarian Chamber estimated the damage at around 10 or 11 billion Czech crowns. At that time, our Intersucho system already worked for Central Europe, and we saw that exactly the same drought impact affected the supposedly perfect landscapes of Austria, Germany, and other Benelux countries. By that I mean that once drought crosses a certain threshold, field size is no longer important. Without water, it simply does not work. Yes, a more diverse landscape may have somewhat greater resilience, meaning the onset of drought can be delayed by several days, but it certainly cannot prevent drought from occurring. In any case, since 2021, Czech farmers may cultivate a maximum of 30 hectares of a single crop, which, if listeners are interested, was a compromise between efforts to reduce field size, divide the landscape, increase biodiversity, and introduce anti-erosion measures, while at the same time maintaining the use of large, heavy machinery that naturally works much better on large fields than in the Austrian countryside, for example.
Returning a bit to Spain and the effects of drought, extreme temperatures, and extreme rainfall there, I have sometimes heard opinions that maybe in the future we could experience a climate similar to Spain's here in the Czech Republic. Is it possible that if temperatures continue to rise, we could encounter Spanish-like climate conditions here?
Well, that is a nicely manipulative question. Incidentally, this was the motto of the government expedition that took place in southern Spain. In other words, let us look at what conditions in the Czech Republic might be like in 50 or 60 years, and how the Spanish are already dealing with them, so that we can get inspiration for what we may have to do ourselves. So, in my opinion, perhaps some of the lowest areas may start to resemble Mediterranean climate conditions a little. But for example, evaporation values. When I spoke about evaporation and transpiration, now combined into evapotranspiration, will still not reach the levels currently found in southern Spain. So, yes, the climate is changing, and changing very rapidly. Everyone who has been farming for more than 30 or 40 years will confirm my words, because they can literally see it happening before their eyes. What existed 30 or 40 years ago has fundamentally changed, and today everything is completely different. But reaching the level of a Mediterranean climate, and of course the next question will be about their crops, fruits, olives, subtropical species, and whether they will be grown here, I would say only very, very limitedly. And since I have already started answering this myself, people often ask, so instead of apples, will we grow oranges here? No, we will not. And the reason is simple, our winters. Even though winters are warming and winter temperatures have increased by 3 degrees Celsius since the 1960s, I said at the beginning of the podcast that the average annual increase was 2.4 degrees Celsius. But winters have warmed even more. We still cannot rule out cold waves, and they will always occur, just less frequently. So if we planted thermophilic trees such as oranges or mandarins here, and once every 10 years temperatures dropped to minus 20 degrees Celsius, everything would die. That is why subtropical fruits will not be grown here. Yes, we already see that some farmers in South Moravia are giving up on apricots because they froze 7 times in the last 10 years, and instead they are trying figs or experimenting with special olive varieties from northern Spain that can survive colder springs. But some massive expansion of subtropical fruit production, I do not see that happening even in 30 or 40 years.
So the climate will basically remain similar, but more extreme throughout the year. Could it be summarized that simply?
No, I would say again that the drier areas will start to resemble the southern regions somewhat more. But let us not forget another important fact. We have already calculated, and we do not even need calculations because we can simply walk through the countryside and see it, that over the last 30 to 40 years, agricultural production zones have shifted about 300 to 400 meters higher in elevation. What I mean is that the conditions we now have in the Vysočina region were what South Moravia experienced 40 years ago. And that also means that conditions in Vysočina have significantly improved. If you look at our maps on climatickazmina.cz or climris.cz, you can see all this for individual meteorological parameters and milestones over 10-year intervals. You will see that temperatures in Vysočina have increased, which is actually beneficial there. You will see that rainfall is still sufficient there, which is also positive. You will see that snow cover is still present, and all of this creates good conditions for agriculture to develop there. On the other hand, in lower-lying regions, we have clearly shifted into drought-threatened areas. So it is a completely obvious shift. But at the same time, I must say it is temporary. In another 30 or 40 years, even Vysočina will begin to face water shortages.
So what can Czech farmers do? Or how can they prepare themselves to cope with these changes?
First of all, these changes are happening very quickly. but not from one year to the next. Everyone who farms can already see them, and those who have already started adapting naturally have an advantage. What can specifically be done? The absolute foundation for agriculture, whether climate change exists or not, but especially under climate change, is soil. If the soil is healthy, not threatened by erosion, not compacted, and not degraded by other factors, then naturally it can retain much more water. Let me give a simple example. It is said that healthy, fertile Chernozem, rich in organic matter, can retain up to 300 millimeters of rainfall, whereas degraded, compacted, eroded Chernozem may retain only 50 millimeters. That is an enormous difference in how much water remains in the soil.
Organic matter content probably plays a major role, right?
Of course. It is said that organic matter can retain up to 10 times its own weight in water. So soil care is absolutely essential. But that should already be obvious. I do not know any farmer who would consciously want to damage their soil. So first and foremost, it is about soil care. Another thing we probably cannot avoid is the use of new genomic techniques. This is an incredible potential that science offers us. I was recently at an important conference where Tomasz Czermak, who works for Ball Horticulture Company in the United States, spoke. He is one of the pioneers of the CRISPR method, these molecular scissors. And when I saw how simply he explained to the audience how a gene causing susceptibility to disease can be switched off, or another gene inserted to provide disease resistance, or how breeding can improve drought tolerance, it was incredible. What prevents these varieties and crops from becoming widespread here? Of course, it is European Union regulations, which are set in such a way that one wonders how it is possible that it works in the United States. He showed us a simple regulatory system, and yes, regulation is necessary. Nobody wants unsafe crops entering circulation. But the question is how these regulations are implemented and whether they actually allow innovation. And I have the feeling that in the European Union, for some reason, they simply do not. So the second adaptation measure is truly the potential of breeding. Then people often say, well, if you do not have water, then irrigate. Yes, irrigation is an excellent adaptation measure. The problem is that when we need water the most, it is often not available. So unless we have irrigation reservoirs and irrigation systems with sufficient water sources, it is very difficult to use this otherwise effective adaptation measure.
Speaking of the CRISPR method, the media recently reported that genetically edited spring barley was planted in Moravia as one of the first experiments. Do you know anything about this project, or was it outside your field?
That is new information for me. But I have other information about spring barley. Namely that farmers in South Moravia are already, I would not say commonly, but quite often sowing it in autumn. That relates to what we discussed earlier. They are trying to establish a root system that will help the crop survive spring drought. Of course, there is one catch. Spring barley is not frost resistant. So when temperatures drop below around -12 to -14 degrees Celsius, winter kill occurs. Naturally, this would not happen if there were snow cover. But in South Moravia, practically nobody has seen proper snow in the last 15 years.
With spring barley, that's true. We've been trying it with farmers. I also have an experience from France, where they sowed mustard in September in the Dijon region. Because of that, the crop had a much better spring development since it was already well rooted. But at the same time, let's say that out of 10 years, it was winter killed 4 times. Still, in 6 out of those 10 years it survived, and thanks to that, they achieved double yields with autumn-sown mustard.
As farmers, we know that year-to-year variability is large and significant. I always say that if a farmer does the exact same thing 2 years in a row, one year it may be a complete success, and the next year it may be a total failure.
And what do you think is currently the biggest obstacle preventing farmers from trying new crops or new practices? Do you think it is fear of poorer economic outcomes? Or is it more of a psychological factor, that things have always been done this way, so why change them now?
I think option B is correct, what you said. But there is also another factor. The average age of farmers in the Czech Republic is 57 years old. 57. And if you have been following certain practices for 20 to 25 years, doing them and believing in them, it is very difficult in the last 10 years of your active career, so to speak, to start learning something new or experimenting with practices that you may not fully trust or may not be convinced are the right path. And then there are opinions like, who knows how it really is, and maybe the climate will start cooling again and things will go back. Yes, I encounter these views quite often. So I think it is mainly a kind of conservatism among Czech farmers. On the other hand, I teach at Mendel University in Brno, where I am the guarantor of the professional agriculture program. Every year we graduate around 25 engineers to whom we explain these new methods, new technologies, and climate-friendly farming approaches. And I can see that the response from these students is enormous. They understand it, and I firmly believe that this new generation will succeed under the new climatic conditions.
You are also part of the Intensifying project, which monitors drought development and overall climate conditions in the Czech Republic. Could you introduce this project in more detail? What can Czech farmers, or even ordinary people, find on this website?
The Intensifying project was launched in 2012, originally as part of a 3-year scientific project. And I'm very proud that the results of this scientific project did not remain in a drawer, as unfortunately often happens with research projects, but that it has effectively continued running up to the present day. This means that, with minimal costs, we are not an NGO, we are scientists and university teachers. The platform still operates today. It is updated every day, and it contains a number of interactive maps. If you move your cursor over any map, you can zoom in all the way to a specific district, or even the cadastral area where you farm. The main pillars include the deviation in water quantity from the long-term average, soil moisture, and satellite measurements. Using satellite data, in this case updated every 14 days, not daily, we can determine the so-called vegetation condition. Simply put, this reflects the amount of chlorophyll. So we can see whether there is more or less chlorophyll in the landscape at a given time. Naturally, during drought conditions, there is less. We can also monitor the relative change since the previous 2-week measurement. In other words, we can observe whether drought is affecting vegetation condition or not. Another extremely important pillar is that several hundred experts are involved in Intensifying, mostly agronomists, who every Tuesday fill out questionnaires about how they perceive drought conditions and what impacts they see on crops. This gives us valuable feedback. For example, if our system indicates severe drought in a region, but agronomists report that there is no drought there at all, then clearly something is wrong. This happened during the first years, and thanks to this feedback, we adjusted and improved the system. Today, it is very refined. Even so, I must say that farmers' own perception of drought is absolutely crucial. There is also a wide range of additional information, including meteorological and agrometeorological forecasts, drought forecasts, both short-term and long-term, up to 6 months ahead. So not only farmers, but anyone interested in understanding how much water there will be in the landscape can find valuable information there.
Do you receive feedback from farmers? Do you also encounter situations where farmers actually adjust their practices during a season based on what they see in intensifying or in the agro-meteorological forecasts?
Well, that is naturally up to them. We are not able to know exactly what is being grown in every cadastral area, and that somewhat limits our ability to provide specific recommendations. Within the framework of our monitoring and data collection, we cannot determine things like, okay, today you have wheat here, last year you had rapeseed. And that is precisely the kind of information we would need in order to provide truly relevant recommendations. So in this direction, we simply cannot go, and we do not attempt to.
But when you speak with farmers, do some of them mention that they actually use it?
Of course. I would say that thousands and tens of thousands of farmers follow it, though mainly as a monitoring tool to see how much water there is in their soil. The advantage of intensifying is that we monitor drought down to a depth of 1 meter, and very few people can assess that directly in the field. Our maps and calculations are based on modeling because these are not direct measurements. In the Czech Republic, soil moisture is measured at only about 50 locations. We, however, work with a 500 by 500 meter grid. That means we process around 320,000 grid cells for the entire Czech Republic, updating them every day. So users can see not only the so-called root zone, which is the top 0 to 40 centimeters, but also the deeper layer from 40 to 100 centimeters. I think this is extremely valuable information because it tells you whether water is available or not. And it also provides a short-term outlook for how the situation may develop. What farmers then do with that information is up to them.
At the beginning, we mentioned that the current drought situation is already rather bad, and forecasts suggest it may become even worse in the future. Does that mean the soil profile is gradually drying out to greater and greater depths?
Exactly. If you download the current map, every map is available there. You will always see labels H1 and H2. H1 represents the 0 to 40 centimeter soil horizon. And today, for example, you would see that around 80% of the Czech Republic is experiencing moderate to extreme drought at that depth. If we look at the 0 to 100 centimeters layer, the percentages are not as severe because, as I mentioned, there is still water in deeper layers in many places. And that is exactly where root systems matter. If a plant has roots that reach deeper layers, water is still available there. But if it has a shallow root system, drought stress begins much sooner.
Intensifying also operates through several additional portals that provide more information. What else can farmers learn from them?
I would especially like to highlight another heavily used portal available at agrorisk.cz. There, we monitor a wide range of abiotic and biotic factors. Abiotic factors are direct weather impacts. Besides drought, we also monitor the danger of spring frosts, winter kill risks during snowless cold winters, and heat waves, which are currently a very serious issue in terms of heat stress. Last year, we even added a system monitoring the overheating of fish ponds. For fish farmers, we know that water temperatures above 28 degrees Celsius can lead to ecosystem collapse and fish mortality. In addition, we also monitor biotic harmful factors, diseases and pests. Using numerous disease and pest models for specific crops, users can select a crop and a region, click on the map or enter their cadastral area, and immediately see the level of risk. For example, in the case of pollen beetles or stem weevils, a red map means there is a very high risk and almost certainty that the pest is present. If the map is white, there is currently no infection or pest pressure. So it is a highly interactive portal where farmers can find dozens and dozens of diseases and pests, along with abiotic risks. It is extremely relevant today. Of course, these are indicative data. Agri-risk will not make decisions for farmers. Farmers still have to go into the field and confirm, okay, the conditions are suitable for this pest. Do I actually see it here? We are not saying the pest is definitely there. We are saying the conditions for its occurrence are either mild or highly favorable.
You mentioned spring frosts. Looking at the forecast, we are expecting another night frost tonight, around -2 to -3 degrees Celsius. At the same time, forecasts for the weekend show temperatures approaching 28 degrees Celsius in some places. These huge temperature fluctuations within just a few days, or even within a single day, seem to have become quite common recently. And of course, they negatively affect crop development. Is this also linked to climate change?
Since the 1950s, our research group has monitored selected species of trees, fruit trees, shrubs, herbs, and even birds in their nesting and egg-laying periods. We inherited this long-term monitoring from our predecessors and continue it today. For example, regarding apricots, which we mentioned earlier, we observe an orchard located in Lednica na Moravia at the Faculty of Horticulture. The records there go continuously from 1951 until today, and the shift in the appearance of the first blossoms over that period is exactly 18 days. That means the time window during which spring frosts can strike has become 18 days longer. I want to stress that spring frosts have always existed, still exist, and always will. They themselves have not changed. What has changed is that vegetation begins flowering earlier, spring arrives sooner, and plants therefore become more vulnerable to these frosts. This year, for example, the apricot trees in this orchard bloomed on March 15th, not April 15th, but March 15th. That means that since then, there have already been 6 nights during which frost damage could occur. And it did occur. I personally know orchards in South Moravia where everything froze 5, 6, 7, even 8 times over the past 10 years. The reason is precisely this shift in phenology. The entire seasonal cycle has moved forward. And this applies not only to herbs and trees, but also to birds such as the titmouse that we monitor. The first egg in the nest now appears about 15 days earlier than before. This is naturally connected with the earlier onset of spring, or more precisely, the growing season. Many of my colleagues still say, the growing season starts on April 1st and ends on September 30th. And I answer them, nature does not own a watch or a calendar. A tree cannot say, it's April 1st, time to start growing. That is simply not how it works. The absolutely dominant factor is temperature. If it is warmer, growth begins earlier naturally. If it is colder, it begins later. And the trend is absolutely clear.
We could actually see this year with rapeseed as well. Vegetation started very early because temperatures were higher, and as a result, the first wave of stem weevils also appeared unusually early. And when it comes to pests, are there any new pests that may start troubling Czech agriculture in the future as the climate continues to shift like this?
Of course. We refer to these species as invasive species. And now allow the teacher in me to come out for a moment, because people very often confuse 3 terms: non-native species, invasive species, and then the incorrect term invasive in another sense. So, invasive in the medical sense is not the correct ecological term. The proper term is either invasive species or non-native species. An invasive species is a non-native species that causes harm. A non-native species, on the other hand, may not necessarily be harmful. So every invasive species is non-native, but not every non-native species is invasive. Hopefully that's clear. What interests us most are the invasive species, those that arrived here and caused damage. I would also like to point out that they do not arrive solely because of climate change. Not at all. Global trade plays a much larger role, meaning transport through seeds and similar pathways. But climate is still highly important. Every organism, including harmful ones, can establish itself only where two conditions are met. First, there must be food available, and second, there must be suitable conditions for reproduction. Food is plentiful here. But until recently, the conditions for reproduction may not have existed. For example, it might have been too cold. So with warming temperatures, their life cycle can now be completed, and suddenly the species occupies the niche and establishes itself here.
Are there already some species that have appeared in recent years in this way? Could you give a few examples?
Of course, there are many examples. For instance, the cherry fruit fly is currently a relevant issue and has been here for several years. Then there are stink bugs, various species of stink bugs. And I think all farmers are very familiar with the western corn rootworm. I can personally remember when we first detected it here. That was more than 10 years ago. Yes, over 10 years ago. It truly was a beetle that came from warmer southern regions and gradually started settling and reproducing here, unquestionably connected with climate change. And today, when I recently spoke with agronomists from Syngenta, they told me that the European corn borer and the western corn rootworm are now practically on equal footing in terms of importance as pests, which definitely was not the case before. Incidentally, speaking of the corn borer, 30 years ago it was only an issue in South Moravia and perhaps parts of the Elbe lowlands. Today you can find it even at elevations of 1,000 to 1,200 meters if maize or other host plants are grown there, because it is not only a maize pest. But we don't even have to stay within agricultural pests. Just look at ordinary ticks. When I was a child and we went to the Yeseniki Mountains, if we brought tick repellent spray, locals would look at us and ask, "Why are you using that? There are no ticks here. It's too cold." Now ticks are everywhere, practically all year round. The pressure from ticks begins very early in the year, especially if we look at the maps that monitor their activity. And in addition, new species are appearing. In South Moravia, for example, they have already detected new tick species that had never been found here before. And with that, naturally, comes the spread of various diseases that these organisms can transmit to humans.
When we look at what farmers should take away from this conversation for the future, what would you recommend most strongly for the next 5 years? What should they focus on the most?
Well, Radim, if I truly knew the answer to that, I wouldn't be sitting here with you. I'd be accepting the Nobel Prize in Stockholm. It's a very difficult question, but I can say that problem number 1 will definitely be water. That means seriously considering all possible measures, including transitions toward climate-friendly farming systems that help retain water in the soil for plants, as we discussed with regenerative agriculture and other approaches. I don't want to make blanket recommendations because it is very complicated, but agroforestry certainly has some potential. Organic farming also has some potential, though please do not confuse it with regenerative agriculture. This approach can also be part of the solution, though only to a certain extent. It is very difficult to give a universal answer, but farmers should genuinely look at alternative crops. I know that when someone says, "Grow sorghum instead of maize," it sounds simple. Sorghum has completely different biochemistry. When drought comes, it essentially pauses, and once the dry period ends, it continues growing from where it left off. It does not simply dry out. On the other hand, sorghum does not form the same juicy ears as maize. And to exaggerate a bit, not that I'm an expert on cows, but cows simply do not like it as much. So perhaps the key advice is risk diversification. It is still better to have at least something, like sorghum, rather than relying solely on maize, which is extremely sensitive to drought. In other words, diversify the risk. Stay informed about what is happening and adapt to local conditions. because adaptation cannot be approached with a universal rule saying, do this everywhere. As I mentioned earlier, conditions in the Vysočina region are actually improving compared to the traditional agricultural areas. So solutions really have to be tailored to local conditions and designed to diversify risks there.
So perhaps the key is not to remain trapped in the traditional approach we are used to, but to experiment with new things, new methods, new crops, as you mentioned. And finally, if you found Mr. Žalud interesting and would like to hear him speak live, he will be a guest at the 4th major Agriculture of the Future conference, taking place on May 27th in Litovice, near Prague. So you may also have an opportunity to ask him your own questions there. Thank you very much for this interview. I think it was very interesting for farmers, and I hope they will take away some valuable insights for the future and perhaps adjust the way they farm a little.
Thank you for the invitation, and goodbye.
Project ReGENERATE is funded by the European Union. Views and opinions expressed are, however, those of the authors only and do not necessarily reflect those of the European Union or the European Education and Culture Executive Agency. Neither the European Union nor the Executive Agency can be held responsible for them.